Hello everyone, welcome to Education Hub YouTube channel and Education Hub tutorial. In this tutorial, you shall be learning how to solve the Paper 2 Computer Science IGCSE February-March 2022. Alright, so problem solving. An algorithm has been written to impute the ages of 100 students, count and output the number of students aged 7 and under 12, count and output the number of students aged 12 and under 18. Now count and output the number of students aged 18 and over. Complete the pseudocode algorithm. Now, it is assumed for the counting variable to hold the number of times that the students that are of this age range are written in the program is the count 7 to 12. It stores the count for students between the ages of 7 and 12, and the count 12 to 18 stores that of 12 and 18, and count over 18 stores the count of students that are over 18 years. Okay, so we are going to make use of a loop, and what we have is 100 students. Okay, now for students 1 to is going to be 100. Alright, for student 1 to 100, because since we are beginning our count from 1, so from 1 to 100 should be 100 students, 100 registrations that will be made. Alright, now output, we are going to make use of prompt. Please enter student's age in years. We want to impute age. Then if age is greater than or equal to 7, that means if age is greater than or equal to 7, we are dealing with this criterion here. If age is greater than, now output the number of students aged 7 and under 12. So age is greater than or equal to 7 is valid at this point. What about this condition which is under 12? So it's supposed to be age and age. We should have an age less than 12. Alright, so we are going to describe everything later. Now again, we have to complete all these empty boxes. If age is greater than or equal to 12 and age is less than 18, then count. How do we count this? We have to increment by 1. So we reinitialize this and we have count here plus 1. And if age is greater than or equal to 18, then we have to also do the same for 18 by incrementing by 1. That's making use of count. Then next, student. Output, there are count 7 to 12 students age 7 and under 12. Output, there are count 12 to 18 students aged 12 and under 18. Output, there are. So I'm going to use because I'm making use of students aged 18 and over, so what should be here should actually be count over 18 variable. So this should be the variable there. Let's walk through it and see how it goes. So as you can see, this colored text are actually the responses to what we have. Alright, for students 1 to 100, and I have my and age less than 12, and I have also count 12 to 18 plus 1, incrementing by 1. Okay, and of course output, there are count over, just like I described earlier. So Let's continue with the next question. Write the extra pseudocode statements that are needed to count and output the number of students under the age of 7. Okay, use the variable count on the 7. We are going to actually write this again. Assume count on the 7 has already been set to 0. So we assume that it's been set to 0, so we have to be incrementing anyways. Alright, so we have if age is less than 7, then count on the 7 equals count on the 7 plus 1. This is incrementing, alright, which is exactly the question we've been asked to execute. Write a pseudocode statement that are needed to count and output the number of students under the age of 7. Use the variable count 7. Assume count on the 7 has already been initialized. Okay. 4 validation checks and 5 descriptions are shown. Draw a line from each validation check to the most appropriate description. So let's walk through this with our response here. Alright, so as you can see, the description for length validation is it checks the data input has 3 digits. Alright, has 3 digits, of course, that's the description. And for check digits, there are 2 descriptions that are actually associated to it. Checks that the data has been input, that's what the check digit does, and also checks that the data input has the correct digits. Okay, it checks the correctness of the digits and also whether or not the data has been input. Range check checks that the data input is between 2 values, that's 2 extremes. Okay, type check checks that the data input is an integer. So we are done with this. Let's proceed to the next one, which is question 4. Okay, now this flowchart imputes a whole number. The function int returns the integer value of a number. For example, int 7.5 returns 7. That's the integer part. Now recall that it doesn't approximate 7 to 8. It simply returns the integer part. So it's very important to take note of that. An input of -1 ends the routine. So let's walk through this. Now start. Input number. Is number equals -1? Yes, then you will end. No, we have to initialize C as 0, and D will be equal to the integer extract of the value entered divided by 2. Alright, is int number over D equals, so we have to take whatever the integer value of number divided by whatever we have from D. Okay, and we check whether it's the same as number divided by D. So the integer value of that division and the non-integer value of the division. Okay, so if it is yes, then we count C equals C plus 1. Alright, and proceed to this. Otherwise, if it is no, we also have D will be equals to D minus 1. We subtract 1 from it, and we check again whether D is equal to 1. If it is no, if it is not equal to 1, then we have to check a decision again. Alright, and if it is equal to 1, then we have to check yet another thing, which is C equals 0. If it is yes, we have to go over to the first and begin here again. Alright, so if it is no, we output C. Remember, the program can only terminate when we have a -1. So let's look at the question that we've been asked. Complete the trace table for the given algorithm using this input. So I have 7, 6, 5, 4, minus 1, 12, 18. So at this point, of course, we know that at this level is going to be terminated. But for now, let's go through this, take it bit by bit, okay? And we get there soon. All right. So you can see that we have the first number entered. Our C should be what? In the first number entered, let's evaluate C to know what we have for C. Is number equals minus 1? No, it is not, because it's 7. Then we initialize C as 0. D becomes integer of 7 divided by 2 should be 3.5. So the integer of 3.5 should be 3. Okay, and we don't have 3 yet because we need to actually look over. Now, is 7 divided by 3 this time around, okay, equals number that is 7 divided by 3? No, so we have to actually have D will be reassigned. D minus 1, that is 3 minus 1 is 2. Is D equals 1? No. Okay, D is not equal to 1, right? And remember, we have not actually concluded on our D. D is not equal to 1. Then we have to go over here is int. Remember, our D is 2 now. Number, which is 7 divided by 2. All right. Okay. Now 7 divided by 2 is 3.5 equals, no, it is not. Then we have to subtract D minus 1, which will give us D equals D minus 1. That is 2 minus 1 is of course 1 now. Is D equals 1? Yes. Is C equals 0? Yes. So our D is equal to 1, okay, and C is equal to 0. Then what do we have? Then we output. Is C equals 0? No, we output C. Okay, if it is yes, we have to go over again and do the same thing. All right, so we have to output nothing because there is nothing to output over there. All right, so we have I think typically output C. Our C should be 0, sorry, so I failed to actually output 0 here, so it should have been 0 over here. All right, so we go through what we have for the next one, which is 6 this time around. Let's go through 6. We have input number, okay. We have the 6 here. Is it equal to this? No, so we proceed. C equals to 0, and D will now be equals 6 divided by 2, of course, is 3, and of course is the integer of that means here we have D to be 3. 6 divided by 3 should be 2, and 6 divided by 3 should also be 2. Is it this? Yes. So we have to count C equals C plus 1. And again, C becomes 1 at this point. And we proceed here and have D equals D minus 1. What do we have as D in the first place? We have that our D should be, recall that we have number over 2, which is 3. So D becomes D minus 1, that is 2 at this point. Is this supposed to 1? No. So we have to check again and we work on this. Is number over D, okay, that means 6 over 2 this time around is equal to 6 over 2 here for rates. Yeah, it is. So we have to actually count, increment by 1. We have 2 at this point in time, and we have D equals D minus 1. That means 2 minus 1, we have 1. Is D equals 1? Yes. So is C equals 0? Okay. Is C equals 0? Yes. No. So C is not equal to 0. We have to output this. Alright, now recall the previous one we did where C is not equal to 0. C is equal to 0, sorry. So we had to actually go all the way and actually impute something. In that case, we don't have any output. So this is actually correct. So we don't have any output here. And we go further and do test for the different values here. Okay, then we have these outputs aligned for us. So let's proceed to the next question, because I assume that you guys can get around it by just taking your time. Describe the purpose of this algorithm. Now take note of this. For us to describe the purpose of this algorithm, you take note of what is in the input side and compare it with what we have in the output. Now this is 7, we don't have any value. This is 6, we have a value. This is 5, no value. 4, we have a value. -1, of course, it terminates, so the rest is history. Okay, so here at this point now, I will notice that 7 is odd, 6 is even, 5 is odd, 4 is even, and these are the numbers that have the even numbers have corresponding values. Okay, now what relates 6 and 2 in this case now, and what relates 4 and 1? Alright, so the only thing to justify this is that it seems like the program is counting the number of prime factors of even inputs. Alright, so of course here it takes me to describing what we have. The purpose of this algorithm is to output the number of prime factors of any even input, just as you can see it. How many even inputs do we have here? Let's just continue. There are 2 even inputs, 6 and 4, before the -1 input, which stops the program from running. Okay, now note, a prime number is any number that has only 2 factors, that is 1 and itself. Also, a factor of any given number is any number that can divide a given number without a remainder. Example, factors of 6 and are 1, 2, 3, and 6, and the prime factors of 6 are 2 and 3, because they each have 2 factors, 1 and themselves. So very, very important to take note of this. Okay. Ooh. Now describe the problem that occurs if this is supposed to be CI. Describe the problem that occurs if a whole number smaller than 4 and not equals to -1 is input. Let's look at the response now. Okay, for CI, if a whole number smaller than 4 and not equal to -1 is input, the program will execute an infinite loop, a loop without an end. So it keeps repeating itself. The program keeps repeating itself. Okay, so when such thing is entered, if 3 is entered, it keeps repeating. If 2 is entered, it keeps repeating. So it will never stop. So that's what happens there. And the next question, explain how to change the flowchart to prevent this problem occurring. Okay, let's look at it. The infinite loop in the program can be prevented by inserting a decision symbol following the no connector of the decision symbol that contains is number equals -1. Alright, so the number, as you can see here, let me show you guys. So where we are going to have is number equals -1. Okay, now the infinite loop can be prevented by inserting a decision symbol following the no connector of this. So after checking this, the no connector, before here we have to insert another decision. Alright, the new decision symbol will contain the decision statement. Is number less than 4? Okay, so now is number less than 4 should come immediately after is number equals -1. Okay, and must end the program if this condition is met. Okay, so if this condition is met, okay, it should connect to the end symbol in order to end the program too. So after checking this, it checks the next one. Then if it is, it should change, it should end the program. So automatically, and that stops it from looping infinitely. Alright, otherwise it connects to the next. If it is not, then it will connect to the next program statement in order to complete the program. Okay, alright, let's go over to question 5. Okay, a database table flower is used to keep a record of the type of flowers available to make up a booklet. Okay, now we have like how many fields? Flower ID, type, color, style, and fragrance. So we have about 5 different fields, and of course flower ID is a text field, that's data type. Type is also a text field, color is text, style is text, fragrance is boolean. So very, very important, we have to reckon this. Now, a query by example has been written to display just the type, style, and color of all flowers that have no fragrance. Now, let me take you back to here. Y corresponds to yes and N corresponds to no. So in this case now, anywhere we have no, it means that there is no fragrance for the selected flower. Okay, so and yes means that there is a fragrance for the selected flower. Okay, so a query by example grid is written to display just the type. There are 3 fields: type, style, and color of flowers that have no fragrance. Now look at the demonstration here. Explain why the query by example is incorrect and write a correct query by example. Now how many fields are required? We have this type, style, and color to be displayed, and we have the fragrance to determine our criterion. Okay, that's whether it's yes or no. Here we have issues. We don't actually need flower ID. Alright, we need fragrance, but we must not display it, so it must not be shown in this case. Now style is needed, is shown, color is needed, is shown, but type is not even there. Okay, so here at this fragrance, while we are not supposed to show this, we have to uncheck it, and the value for the criteria should be N, not Y, because we want the ones that do not have no fragrance. Okay, so let's look at how this is. Type of flowers is not displayed. This is the explanation. Flower ID should not be displayed. Fragrance field should also not be displayed. The criteria, the fragrance, which should be equals N, since flowers with no fragrance are required. Okay, so and this is exactly how the new thing should look like right now. Alright, so thanks for watching, and if you don't understand, if If the video is too fast, then I recommend that you always pause and internalize before you play back again, just to help you understand better. So watch as many times as possible for you to be able to comprehend. So I wish you all the best, and please try to subscribe for subsequent resourceful videos like this, and click on notification buttons to be alerted whenever more videos like this are uploaded. Thanks for watching. See you next time.